Hey, calculus people. I'm back here bringing you some more content. Make sure you hit that subscribe button, smash the like button if you like this content. Um, yeah, I'm gonna help you out with a couple of these, just to make sure you're cool with it, um, just to get you in the groove. So I'll do. Let me do. I don't know. I want you to do these two because they're different. Like this one, you're going to have to use the quotient rule. This one, you're going to have to use the ninja rule. I kind of like that. Let's see if you can do that. So maybe I'll do this kind of mean one here. All right, number 2 is a little mean with product rule. If you can do number 2, number 1 seems easy. So all of these say differentiate with respect to x and find the slope at the indicated point. That doesn't mean find the equation of a tangent line, which I could, but all I got to do is actually plug in my answer with like the x for x and the y for y and get a slope at each point. So I'm going to differentiate with respect to x, which means take the derivative with respect to x. And in implicit differentiation, if the letters don't match, you have to pay the penalty of a prime. So I'm going to take the derivative of this guy and the derivative of this guy and the derivative of that guy. Well, the right side's pretty easy, right? Derivative of negative 2 is 0. Still a thing, all right? When I go to take the derivative of this one, I notice that it's multiplication. It's not as easy to see in these problems as your other problems when you see like big sets of parentheses times each other when you're doing normal product rule. But this is a product rule. Here's u and here's v. So I'm going to write u prime v. Now I didn't need a penalty here because when I take the derivative of an x, it matches the letter we did. So dx over dx goes away. But when I do v prime u, right, when I do v prime, it's 2y. You still take it as if it were, you treat it the same as if you would an x squared, except since it doesn't match the letter, I have a penalty. Okay, so there's the derivative of the first part. Plus, now we go to the second part. Oh no, it's another product rule. Here's my u, here's my v. Now when I do u prime v, when I do u prime, it doesn't match the letter. So I'll do 2y, y prime, and then v is just an x. Oh wait, did I forget my u here? There's v prime. I forgot the u. Ooh, good thing I left room. That would have been a rookie mistake. Right? U prime v, v prime u. Here I have u prime v plus v prime is just 1. You don't have to write the 1 if you don't want. And then u. There's no penalty for taking the derivative of that. And you don't put penalties on ones you didn't take the derivative of. So I got all that. Awesome. My next step is, if my goal is to find the slope, that's y prime. Get y prime by itself. So now it's like a big old ugly algebra problem where my goal is to isolate this guy and this guy. So my first step is always to get rid of the things that don't have y primes in them. And you just do it by subtraction. So I'm going to move this guy to the other side and call it negative y squared. I'm going to move this guy to the other side and call it negative 2xy squared. On the left side is going to be the two things that were left, which is 2y, y prime, x squared. You can change the order around if you want to like bring the y prime to the back or bring the y prime to the front, or you can leave it in like I am because it doesn't matter. Okay, now I have gotten all the y primes at least by themselves on one side, but they're not isolated. If you have more than one term with a y prime, you need to take it out as a GCF and just write whatever is left inside. This is why it didn't matter if I didn't rearrange the order, because now if I remove a y prime, I have 2y x squared and a plus sign, and I remove the y prime from this guy, and I have 2yx. Now I'm almost done. I just have to divide. To isolate this, I just have to divide both sides by, this weird thing. Whatever I do to one side, I got to do the other. 2yx squared plus 2yx. So y prime, my slope, is negative y value squared minus 2 times the x value times y value squared over 2yx squared plus 2yx. Boom. And I'm almost done. That's awesome. I found the derivative, right? Boom. Now I just need to find the slope. And I used 2 for x and negative 1 for y. So I'm going to write, let's see if you can type this in right. When you square that, that negative sign out in front is still going to stay there. So negative 1 squared minus 2 times negative 1 squared. Use parentheses, you'll probably get this right. If you don't, then you don't know PEMDAS, and you have to hang your head in shame. But don't hang it for too long, because we all make mistakes. I try to teach my daughters. Mistakes are how you learn, as long as you go back and try to correct it. Alright, so let's try this one out. I'm going to pause while I do the calculating, because you don't need to see that. Alright, after some fancy calculating, I typed all that in. I got negative 5 on top and negative 12 on bottom, and I get 5/12 as the slope at that point on this crazy looking graph. This would be, I don't even know what shape it is, but it would be nuts. It's not going to be any normal shape that you're used to. Alright, so if you can do that, you go back here, and this one's easier because there's a lot less product rule going on. There's a little product rule. This problem, I'd like you to do it. You're going to have a little quotient rule to see if you remember the whole low D high thing. Remember, you only need the penalty when you're doing the derivative of a letter that doesn't match x. So for the whole low D high, you don't have to worry that much. This one's a little sneakier because you have a chain rule going on. And when you go to take the derivative of the inside, once again, you only pay a penalty on the part that doesn't match the x. So I want you to try both those because they're different and they're kind of applying skills. I don't know, maybe this one just for old time's sake. Just to see, the numbers get kind of ugly. So you're going to take the derivative with respect to x of each piece. So this one's easy, 0. Derivative of 5 is still 0. Derivative of x to the 2/3 is 2/3 x to the negative 1/3 because you're subtracting 3/3. And then this one's almost the same. You got 2/3 y to the negative 1/3, but then I have a penalty of y prime because it doesn't match my letter. Okay, that's the whole thing with implicit. Now the good news here is I only have one y prime, so it's not going to be a ton of work to get it by itself. I move this guy to the other side, right? Negative 2/3 x to the negative 1/3. Now I recommend at this point, oops, where did my y prime go? Hold on. I recommend at this point to rewrite these so there's one fraction, because remember when you see a negative exponent, it means this guy drops to the bottom. So really I could write this as 2 over, there already was a fraction, 2/3, right? There's my 2/3. If this has a negative exponent, it just means it's supposed to drop down to the bottom and become a regular 1/3. So I'm not really doing anything other than rewriting my problem. Same with this other side. Cool. Now, if my goal is to isolate this guy, the good news is if you're multiplying by a fraction, you can undo it by multiplying by its reciprocal, as long as I do it to both sides. So if I multiply this side by 3y to the 1/3 over 2, I can multiply this side by 3y to the 1/3 over 2. And these go away. That was the whole point of it. And the other side simplifies quite a bit too. The 2's cancel, the 3's cancel, and you're left with, don't lose your negative sign, left with negative y to the 1/3 over x to the 1/3. Now I can plug in my x and y, but it might be easier on your brain if you rewrote these as cube root of y and cube root of x, because it's a whole lot easier to plug in an 8 and a 1 to these things. So I'm going to have, that's my answer. I guess I could have circled the one above it. But I'm going to plug in a 1 for y, so negative cube root of 1 over cube root of 8, which is negative 1 over 2. It has a slope of 1/2, negative 1/2, at that specific point. Okay, so you can probably do the rest. Number 6 is a lot like number 1. You're going to have some penalties. Maybe I should do one. Yeah, let me do one of these where you have x's on both sides, or y primes on both sides of the equation, just to show you. So maybe, I don't know, number 7. Let's do number 7. All right, last problem. So it's not that hard, again, but you're going to apply the d over dx. You're going to differentiate with respect to x on each piece. When I do it to the 1, I get a 0. When I do it here, I got to do the product rule. So I got a u and a v here, right? Attach the negative sign to this guy. Maybe call it a negative 1 if it helps your brain, right? So derivative of that's 0. Derivative of this, what's the derivative of u? So u prime v. U prime would be a negative 1, no penalty, because it matches the letter. And v is y, no penalty. I'm not taking its derivative. Plus v prime u. Well, what's v prime? It would be a 1, or 1, but there's a penalty because it doesn't match the letter, so 1y prime. And then u is just negative x, sorry, because I attached that negative sign to it. And now the other side's pretty easy. What's the derivative of plane x? A 1. What's the derivative of a minus y? It's minus 1, but there's a penalty, so you got to put a y prime. So when you're all done with that, you notice that there's y primes on two sides of the equation. It's kind of your call. Do you want to take them to the right? Do you want to take them to the left? Doesn't matter to me. Whichever way makes less movement. But in this case, looks like I got to take this guy to that side. You don't have to. I'm going to take this guy to that side. I don't know. I just like having the y's on the same side of the equation. So here I have y prime times negative x. And I brought over this guy with addition, so it becomes a positive y prime. The other side already had a 1, and I'm bringing this guy over, and it'll be a plus y. All right, so now I got my y primes to the same side. Now I need to take it out. Here's where you could be a rookie. If you just wrote negative x, you're going to get it wrong, because negative x is the first part, but what happens when you take a y prime out of a y prime? You're left with just plus 1. Okay, imagine distributing it back and see what you get, right? Y prime times negative x, y prime times 1. Oh yeah, it does work. Okay, last step. Whatever you do to one side, you got to do the other, and I got to fix this thing, get y prime by itself. So 1 plus y over negative x plus 1. Or if you want to write it as 1 minus x, just for your benefit, that's cool. But that's your answer. Now, to get my slope at that point, I'm going to plug in an x of 1 and a y of 0. So y prime is 1 plus 0 over negative 1 plus 1. Ooh! That means it's undefined. We found a asymptote of some sort. That's crazy. All right. Well, what are you going to do? Things like that happen, especially when I make up problems. All right. Well, I will talk to you guys later. Hope that helped. And do the rest of them. Especially interested in what you do on number 3 and 4, because I think they're kind of cool. They're different. They're not just product rule. All right. See you later, folks.